we have studied previous session chain rule. Now we can move without chain rule. Directly we can use chain rule. Now today we shall study directly without assuming T equivalent. For example, let us consider y is equal to sine cube x. Now, what is differentiation of this function? That is, we have to find dy by dx. Now, we can use chain rule by assuming sin x as t, but now we have to proceed directly. Now, y is equal to, we have to assume t origin, sin x whole cube. Now that is the whole cube of sin x. Now we have to differentiate treating as t origin, that is dy by dx is equal to 3, if we treat as t, 3t square, that means sin x whole square. Now differentiation of this with respect to x, that is d by dx of sin x. Now that is 3 sin square x d by dx of sin x is awesome. That's all. So we can ensure differentiation without spending time as well as space. Again, we consider y is equal to under root cos x square. Now, first of all, we have to consider cos x square raised to the power half. Orally, we may assume cos x square as t. In that case, dy by dx, we have to write directly dy by dx. That is t raised to the power half. Differentiation of t raised to the power half is half t raised to the power minus half, as you are familiar. But instead of t, directly we can put cos x square raised to the power minus half. And again we have to write d by dx of what is here in place of t, that is cos x square. Now that is equal to half cos x square raised to the power minus half. D by dx of cos square means, again we have to assume x square as t, because we are not familiar direct differentiation of cos x square. We are familiar for differentiation of cos t. That means that is minus sin x square and d by dx of x square, as we have assumed x square as t. Now we may get half under root cos x square minus sin x square into 2x. 2 cancels 2, answer is minus 2 sin x square upon under root cos x square. That is all. Again we have solved the problem. Similarly, we will proceed for others. Before taking next problem, I would like to describe that there are three other formulas regarding inverse. So, besides 10 formula, I am giving you 3 formula for inverse, that is d by dx of sine inverse x is equal to 1 upon under root 1 minus x square is equal to d by dx of minus cos inverse. Or we may convert this into formula if you are interested, that is d by dx of sine inverse x is equal to 1 upon under root 1 minus x square and d by dx of cos inverse x is equal to minus 1 upon under root 1 minus x square. Similarly, we can write for other inverse circular function. Now, we make in tabular form, we will consider 6 formulae instead of 3. Say y and d by dx. You will learn these 6 formulas. Sine inverse x, that is 1 upon under root 1 minus x square. Again, cos inverse x, I have already described, wherever there is O, there will be negative sign, minus 1 upon under root 1 minus x square. Now consider tan inverse x. Differentiation of this is equal to 1 plus x. Cot inverse x, that is minus 1 upon 1 plus x square. Sec inverse x, that is 1 upon under root mod of x square. That is 1 upon mod of x under root x square minus. Similarly, there is cosec inverse x हो आ गया तो माइनस mod of x under root x square minus. These are the 6 formulas. How will we derive? That will see later on. In future, we have to observe how will we get. Now, you may remember these 16 formulas. However, these may be converted into 3. As there is a difference of only negative sign for co. Now, let us consider y is equal to sine inverse x square. How will we get dy by dx is equal to, if we assume sine inverse t, x square as t, so we may get under root 1 minus t square, that is x raised to the power 4, and d by dx of x square, what it is here. That means 2x upon under root, that is quite simple, x, 1 minus x raised to the power 4. Similarly, we take another example. Suppose y is equal to cot inverse under root x. How will we get differentiated? that is dy by dx will be 1 upon co is there minus 1 upon 1 plus root x whole square, and instead of x there is root x, d by dx of root x, that is minus 1 upon 1 plus x, d by dx of root x means half root x, that is minus 1 upon 2 root x, 1 plus x, that is the differentiation of this function. Now take another example, that is for y is equal to sec inverse x square under root x square minus 1. How will we get dy by dx? Instead of x there is under root x square minus 1. That's being replaced to all, you may assume already this whole factor as t. Now we might be knowing differentiation of sec inverse x is 1 upon mod of x under root x square minus 1. So mod of this x square minus 1 under root x square minus 1 means under root x square minus 1 whole square minus 1. And now what is in displacement of x, that is under root x square minus 1, d by dx of under root x square minus 1. Now I think you might be already been familiar in previous example. 1 upon under root x square minus 1 as under root x square minus 1 mod means that is positive part. Here x square minus 1 and that is d by dx of x square minus 1 raised to the power half. Now that will be under root x square minus 1 under root x square minus 2 and d by dx of this means 1 upon 2 x square minus 1 into d by dx of x square minus 1, as we have assumed already as t raised to the power half, that is t. Now here what happens, x square minus 1 under x square minus 2, that is 1 upon 2 under x square minus 1 into 2x, d by dx of x square minus 1 means 2x only, and 2 cancels 2, that is equal to, if we simplify we will get x square minus 1 under root x square minus 2. That's the answer. Now if we are interested to find sec inverse under root x square minus 1 at x is equal to, find this value at x is equal to suppose 2. In that case put the value of x as 2. Now you may get, finally we have to put as 2, that is 2 upon under root 4 minus 2, here 2 square minus that is 2 upon 3 under root 2, or you may write 2 upon 3. That's the answer. Now we take another example. Tan inverse y is equal to tan inverse that is somewhat lengthy procedure if you substitute time to time as t. Now we may get in a systematic way by assuming already that is dy by dx is equal to 1 upon 1 plus 1 minus 1 plus x whole square, as we have replaced this as t. Now d by dx of what is here, we have to write directly what is here. We have not to think regarding the expression, because we have to write this expression only. Now we have to differentiate this by making further change. That is 1 plus 1 minus x upon 1 plus x. Simultaneously, you may simplify it and proceed this step further. That is d by dx of the whole. How will we get? We may assume d by dx 1 minus x upon 1 plus x raised to the power half. We may assume this as whole. That is t raised to the power half. Now, what will we do? We may simplify simultaneously, that is, we are getting 2 upon 1 plus x into, how will we get? Half is, we assume that is t, half 1 minus x upon 1 plus x raised to the power minus half, as t raised to the power half is differentiated to be t raised to the power minus half. Now d by dx of that is t. Now what we get, that is 1 upon 2, 1 upon x. That will go in numerator and 1 upon 2 further, and 1 upon minus x, 1 plus x raised to the power half. How will we get? You may use quotient rule for this. That is 1 plus x whole square, d by dx of 1 minus x into 1 plus x minus d by dx of 1 plus x into 1 minus x. Now we will calculate further this. After this step we will take on the top, that is 1 upon 4 into 1 plus x. 1 plus x upon 1 minus x under root, and we may get it 1 plus x minus 1 plus x and minus minus 1 minus x upon 1 plus x whole square. Now we may simplify it. That will cancel, I think. This will cancel out. Now we may simplify. That is minus 2 will cancel out. This, and we may simplify it. How will simplify? That will be simplification. 1 upon 2 under root 1 minus x square, and we are getting here. I think that must be the answer. That's all. Thank you.